Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Galiz 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Galiz 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Galiz 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the Sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. Pluto, an exoplanet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water-ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first half-billion years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Triton, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to -37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind – hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular – lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their 2 cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, 2 cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas.
Imagine swimming in a salty ocean deep beneath the icy shell of a moon. There are geothermal vents around you, and they provide the energy tiny microbes need to survive. Or exploring a moon covered in rivers of methane and ethane, where life could be hiding in the depths of craters. The point is, we may not need to leave our own solar system to look for any sign of life outside of Earth. Icy moons could rewrite cosmic history with oceans sandwiched between an ice crust and a hot planetary core. Something unexpected happened in 2005. While visiting Saturn, the Cassini spacecraft flew through a fine water mist. It was spraying into space through cracks in the surface of Enceladus, one of Saturn's moons covered in ice. And the water was coming out at a crazy speed of 802 miles per hour. Cassini wasn't built to sample water, but it was still encouraging for scientists to discover something like that. They developed new missions where they wanted to focus on the icy moons of the outer regions of our solar system. On our home planet, water is the base for life, as we know it. And now, at least 6 moons might be spots where we could find watery oceans. 1 orbiting Neptune, 2 circling around Saturn, and 3 traveling around Jupiter. Scientists study extreme environments on our own planet to understand and guide their search for extraterrestrial life. For example, take such places as deep-sea volcanic vents and frozen lakes in Antarctica. They can tell us more about what conditions could support life on other planets. And these missions are led by a team of experts from different institutions that joined into something called Network for Ocean Worlds. They hope to finally find some life outside of Earth. Come on there, we need some new friends. So, hello there, Europa. Picture a frozen moon covered in double ridges that crisscross its surface like scars. Recently, scientists have discovered something exciting. There may be shallow pools of water on Europa, right under its icy surface. These ridges are very similar to those found on the Greenland ice sheet, and if they formed in a similar way to those in Greenland, these pockets of subsurface water may be common on Europa, hiding just beneath its frozen surface. Such pools form when subsurface water freezes and fractures the surface again and again, pushing up twin ridges. It's like when you put a can of soda in the freezer, and it explodes, pushing up the ridges on the surface. These ridges on Europa are up to 984 feet high and separated by valleys half a mile wide. And you know the rule, where there's water, there may be life. Chemicals that are necessary for life may be circulating from the icy shell down to the salty ocean far below the surface. And Europa has already been one of the most popular moons in our solar system when it comes to looking for extraterrestrial life, considering there's a deep ocean beneath its icy shell. Scientists believe this ocean could be 40 to 100 miles deep, which means it could hold twice as much water as all of our oceans combined. Another candidate is this tiny moon called Enceladus, which is about as wide as Arizona. Despite its small size, scientists think it could host some life, just like Europa. The reason? Again, a liquid water ocean and a thin layer of ice that covers it. In 2008, NASA's space probe, Cassini-Huygens, detected plumes of salty water vapor going out from the moon's south pole. Scientists analyzed the plumes and found organic molecules like carbon, nitrogen, and oxygen, which are important building blocks of life. Instead of a thick ice cap, like Europa has, Enceladus might have a thinner coating of ice mixed with crust. The plumes are really fast, which tells us they could be produced by a liquid ocean present at the moon's south pole. Scientists believe that on Enceladus, there's a constant process where water vapor rises up from the surface, then falls back down and turns into liquid water again. And it's been happening for hundreds of thousands of years. This movement could help distribute organic molecules that scientists think are necessary for life to exist. So, there's a chance for tiny living things crawling somewhere on Enceladus. Earth is a pretty awesome place, and there are a lot of factors that make it friendly to life as we know it. But when it comes to finding life beyond our planet, we can't just assume every other place in our solar system needs to have all these factors to have any signs of life. And one of the most promising places is definitely Ganymede, the largest moon in our solar system. It's gray and covered with craters, and it may look boring at first glance, but don't let its dull appearance fool you. We've recently discovered there's water vapor in its atmosphere, and there's more to it than just water. On Earth, we have a lot of other fun and useful factors that make it a good place for life. We have a magnetic field that protects us from harmful radiation, and a big moon that creates tides that help mix up our oceans. We also have a deep liquid water ocean and land masses with different elevations that create a variety of environments for life to thrive. Ganymede has some of these factors as well. A magnetic field check. Plus, it's Jupiter's biggest moon, so tidal forces are present there too. Ganymede is tidally locked to Jupiter, which means it always shows the same face to the gas giant. But even though it's so close to Jupiter, Ganymede still manages to rotate around its own axis every 7 days. A magnetic field and strong tidal forces are factors that could help create and maintain a liquid water ocean deep beneath the moon's icy surface. And this ocean may not be just for potential galactic vacations. It may also harbor life. Let's head to Io, the third largest Jupiter's moon. We're talking about a very special place since it's the most volcanically active body in our solar system. Yep, there are more than 400 active volcanoes that shoot out gas and other stuff there. This helped with creating a thin gas atmosphere, mostly made of sulfur dioxide with traces of oxygen. Volcanoes also make certain parts of Io really hot as 3,000 degrees Fahrenheit. Some other areas are very, very cold, minus 202 degrees Fahrenheit. Life could hardly develop in such extreme conditions. Plus, Io doesn't have water or organic chemicals, and it orbits within a ring of dangerous radiation. But scientists believe there might have been life on Io a long time ago, maybe even in some other form that we don't know about today. It could still be there, deep under the moon's surface. Some simulations suggest that Io formed in an area with lots of liquid water, which combined with its heat could have fostered life. But any life on the surface would have been destroyed by the radiation after only 10 million years of existence. So, if there's life on Io, it's probably deep underground, safe from all the crazy radiation at the surface, like people building entire cities in all those apocalyptic movies, hiding from whatever's out there on the surface. So to check that out, we'd need to send a special probe to find it. But building a probe that could land on Io and drill deep enough to find life is a very big challenge, and we're not quite there yet. Mars is a planet that scientists have studied a lot. They believe the red planet used to have liquid water and freshwater lakes on its surface. It's way better than what we have at the moment, just some plain ice caps on Mars' poles. But there could be some organic compounds present in its crust. These days Mars is extremely cold and has a thin atmosphere, not very promising. but some scientists think the red planet used to be much warmer and more hospitable. Hopefully all those rovers and probes will bring us some awesome news and evidence of life.
The ocean is turning red hot. You try to get closer for a better look, but you start feeling the air getting hotter and hotter, like reaching into an oven. And the sand is so hot that your rubber slippers start melting. The ocean's somehow turned into steamy, hot, gooey lava. You start running inland and see a frenzy of people running wild. See, in reality, lava is made of molten rocks from below the Earth's surface. Deep inside our planet, like the distance between New York and Philadelphia deep, the underground heat from the core melts rocks the same way the sun melts ice cream. When these rocks melt, their temperatures can reach around 2200 degrees Fahrenheit. But don't worry, that only happens really deep under the ground and only in some specific areas, mostly around the Atlantic Ocean. And it only pops out of the ground when there's so much pressure that it flows up to the surface as a gooey orange super hot liquid called lava that usually erupts through a volcano's neck. But somehow, the entire ocean is made of lava now. And although from a really far away distance, it looks pretty cool to look at, it's really dangerous. First of all, say goodbye to the beautiful blue waves and the ocean currents. Unlike water, lava is thicker, closer to creamy peanut butter in texture, so the wind can't move it around like it used to. But that also means that nothing can sink or swim in it. So even if some ocean creatures could withstand the super high temperatures of lava, they won't be able to live inside of it. They'll either be submerged or float on the surface instead, depending on their density. So, all our marine friends and other creatures that used to call the ocean home will need to find another body of water to live in if they want to survive. Actually, the only animals on this planet that could possibly survive the heat of lava would be the tardigrades. These cute microscopic creatures can survive in any extreme environment on this planet. From frozen icy glaciers to hot and fiery volcanoes. They can even survive in outer space under the cosmic rays. You run away from the beach along with everyone else nearby. The atmosphere is getting thicker and it's not easy to see around you. You think to yourself, I should have stayed home. But home isn't exactly safe either. The heat radiating from all the lava alone would be intolerable for miles. So no more houses by the sea and beach resorts. You're gonna want to make sure you live as far away from the ocean as possible. Most of the coastal cities would become instantly uninhabitable, especially areas touching the ocean with more than one side. Places like Florida, California, and Central America would become mostly unbearable to live in. And that's not to mention island life. Most islands would be so hot that no animal or plant could survive. 97% of the planet was made up of ocean water, and it now all turned to lava. No place on Earth can hold snow anymore, as the planet would look like a glowing orange lava ball. Temperatures would rise so much that the furthest place from the shores and even the highest peaks will still feel like the hottest day in a desert. As you keep running away from the ocean, you realize that maybe you're dreaming, but you look at your skin and see so much redness. Even if you run for miles, the heat will still catch up to you. All the offshore oil rigs and ships in the middle of the oceans will face plenty of problems too. Their metallic composition would simply glow red and melt instantly when in contact with hot lava. And even if it doesn't melt, you better hope nobody happens to be on it. But in any event like that, they would have evacuated everyone. Meanwhile, at the North and South Poles, where the planet is at its coldest, all the ice that was covering the ocean is instantly melting in contact with the lava. It would then cool down and solidify into rocky black landmasses called igneous rocks that are often glassy in texture. The moment the hot lava cools down, huge clouds of acidic steam and gases get released into the air, covering the sky. Scientists call those lays, which is a combination of the words lava and haze. Kinda like when you exit the shower and all the heat comes in contact with the cold outside air, creating a haze. Except this one would cover the whole North and South poles, and it would be super toxic. It sometimes even contains tiny glass particles that are extremely hazardous. And this gliese can travel around the world with strong enough wind and cover almost the entire northern hemisphere. It could also cover the southern part of New Zealand, Argentina, South Africa, and Australia. Flying an airplane through this gas wouldn't be the best idea. The heat alone emitted from the lava would be enough to cause major damage to the exterior and affect the airplane's hardware. It's a good thing you found your trusty oxygen container. The air is barely breathable at this point. You make your way to your car and drive away as fast as you can. But even your car's taken some damage. You drive out to the countryside, where the atmosphere hasn't been affected by the lava yet. But even all the way out here, the temperature is changing. The river you used to see on your weekly hikes is drying up. The plants around you are losing their green lush. The animals around have migrated to a different place. Rivers flowing into the ocean would simply create mounds of glassy igneous rocks upon contact, permanently creating natural dams. The rest of the water inland, like in ponds and lakes, would eventually evaporate over time. With the rise in temperatures and no rainfall, it would be the end of water on the planet as we know it. The huge mass of ocean water plays a major role in creating clouds and rainfall. Without water in the atmosphere, the sun's heat would add to the lavas. The world would be a huge barren wasteland. The nights would be hot and the days even hotter.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Still, lava cools down eventually in contact with the cool air. So soon enough, the surface would start forming a thin layer of black crust that would gradually thicken over the years. The thicker the lava, the longer it takes to completely cool down on the inside. It would still be super hot though, but at least if you touch it, you won't be directly touching the burning lava. That's actually how many islands were formed, like the Hawaiian Islands, for example. They're fully formed by lava erupting from below the ocean that dried over hundreds of thousands of years. It accumulated layers over layers of solidified lava from below the ocean until it rose above the surface, forming islands and even mountains. As we speak, a new landmass in Hawaii is being formed by an active volcano. Scientists expect it to be a new fully formed island in about 10,000 years. So now, the view that used to be the blue ocean turned into steamy glowing orange slime that will in turn quickly transform into a solid black wasteland. But don't think you can easily walk over that ocean. It could take hundreds of years for it to fully cool down and turn into solid rock. Until then, walking on that dried lava crust would be similar to walking on a frozen lake, except that in this case, one misstep would cause you to fall into boiling hot lava instead of ice-cold water. Some regions would even take thousands of years to fully solidify. The Mariana Trench, the deepest region of the ocean, is about a whopping 43,000 feet deep. It would actually take at least 5,000 years for that much lava to completely cool down. There are many planets out there that are so-called lava planets. A recently discovered planet, K2-141b, has magma oceans, supersonic winds up to 3,000 miles per hour, and even rocky rains. That's right, the planet is so hot that it vaporizes rocks and rains them back down. Keep in mind that this planet is much closer to the sun than our planet is. Maybe their oceans once turned into lava overnight.
Magma oceans, supersonic winds, scorching hot days, and instead of rain, a bunch of rocks falling on your head. Just another one of those days, huh? Astronomers recently discovered a new superplanet out there. K2-141b is an exoplanet that's around 200 light-years away and in serious need of a new name. An exoplanet is just a fancy way of saying that a planet orbits its own star in another solar system. The Earth orbits the Sun, so this planet has its own orbit party going on. So what makes K2, bunch of numbers, so scary? Picture our beautiful little blue planet Earth. Now imagine that all the volcanoes in the world suddenly erupted at the same time and lava covered the oceans and seas. Fiery hurricanes, thousands of times faster than normal, blow all over the place, 24/7. And it starts raining rocks every now and again. Rocks, like on your head. Thankfully, not in your head. This scary planet came into our lives about 2 years ago. Scientists are still studying it. So, what's a typical day like? For starters, you can forget about breathing. Oxygen decided to take a pass on this planet. You'd have to get used to sodium, silicon monoxide, and silicon dioxide, which is, as you guessed, not great. And that's just scratching the surface. Who knows what other chemicals are lying around? And yes, magma oceans. The planet's surface is covered in molten magma as far as the eye can see. This lava planet orbits really close to its star, which is why the surface is like a fireplace. The closest planets to our Sun are Mercury and Venus, but this planet's even closer. And what's even more weird is that half the planet is in constant daytime, the other half night. It's tidal locked, just like our moon is. No matter how long you stare at it, you'll never see the other side. That's why the all-day, everyday scorching fiery side is so hot and overflowing with magma oceans, while the other side's in a constant state of deep freeze. If the magma doesn't burn you, you've still got big problems, and please don't look up, it's raining rocks. On Earth, water turns to steam, rises up, becomes clouds, cools, and falls as rain. Over there, on planet Fireball, it's exactly the same, except for it's rocks, people. The planet's so hot, it vaporizes rocks. Oh, and don't forget the supersonic winds with speeds up to 3,000 miles per hour. Imagine your hat getting blown off your head at 5 times faster than an airplane. The strongest wind on Earth was the tropical cyclone Olivia that hit Australia. It was blowing at 250 miles per hour. Now imagine 12 times that. On the sunny side of the planet, you're looking at a roasting 5,000 degrees. The hottest it ever got on Earth's surface was in California, 135 degrees. It's pretty common for it to get near that temperature in the Sahara Desert, but that kind of heat's not exactly enough to make rocks evaporate. If you grew up near a desert, you already know how dry and hot it always is. But did you know that deserts can reach freezing temperatures? A desert, by definition, is a large area with little or no rainfall. That means no water vapor to keep the temperatures from going insane. In the daytime, the sun heats up the desert like an oven. But when the sun sets, the heat packs up and heads home, and it can get really cold. Some deserts have even reached minus 40 degrees at night. But wait, shouldn't deserts have snow if it's that cold? Well, some deserts have had a bit of snow here and there, but because there's no water vapor, there can't be that much snow. Just dry, freezing, sandy Sahara nights. Now, the Sahara Desert's actually not the largest desert on Earth. It's Antarctica. 5 million square miles of icy dryness, almost no people, and a whole bunch of cute penguins. Penguins technically live in a desert. Back to the Fireball planet, this time the night side. Never-ending darkness and extreme cold, about minus 330 degrees. Add in some supersonic winds? Earth's coldest? Minus 130 degrees at a research center in Antarctica. So, how does this jalapeno pepper exoplanet stack up against some of our neighbors? Well, Mars isn't exactly livable either. It's the red planet, so you'd think it'd be hot most of the time. But it's usually freezing, well, way below freezing. And if you're planning a weekend getaway to Mars, you can leave the umbrella at home. Nah, it doesn't rain rocks, and it actually hasn't rained there for millions of years. At least Mars has days and nights, and it's like Earth in other ways. Mars' equator is steamy hot, and it gets pretty cold at the north and south poles, just like Earth. Scientists even discovered old bits of carbon dioxide snow there. The entire planet is actually covered in carbon dioxide, with a splash of nitrogen here and there. Scientists even reported intense snowstorms on Mars. But because it's mostly carbon dioxide, it's not your typical snowstorm. It's more like a dry ice storm, That's the stuff they use in fog machines. Mars isn't the only place where climates are going cuckoo. Jupiter's famous for its gigantic storms. Not like the ones we know on Earth. I'm talking about storms that last for centuries. The Great Red Spot on Jupiter is actually a 400-year-old storm, and you could fit 4 whole Earths inside of it. So it's been around for a while, but it's nowhere near as intense as the storms on K2. Venus also has intense rain, but it's not made of rocks. It's sort of worse. It rains sulfuric acid. That stuff can give you severe skin burns and rip nasty holes through your umbrella. Venus's atmosphere is filled with carbon dioxide, which acts like a net to trap in the sun's radiation, and it's insanely hot. No magma oceans, though. Mercury is the closest planet to the sun and doesn't even have an atmosphere. That means no storms, clouds, rain, wind, whatever. Mercury is kind of like a desert here on Earth. No water vapor and no rainfall. That means temperatures shoot up during the day and drop like crazy at night. The K2 exoplanets, like the most extreme parts of all of our solar system, all rolled into one scary planet. But we're not headed there anytime soon. We haven't even been to Mars yet. That's all way off in the future, and 200 light years is a really long travel time. If we're going to move anywhere anytime soon, we'll probably want to set up camp on the moon. No magma oceans, no warp speed winds, nice temperatures. So, where would we even start? Well, the main issue is that drones and remote control robots are getting more and more advanced. It's way cheaper to send them over to map out the moon for us while we're safe here on Earth. And if we ever want to begin space exploration for real, we'd need a proper space base. And what better place than our little shiny moon? So, why do we even study those far-off planets? What's the point? Well, planets are like people. They're all different ages and live in all different places. The more of them we study, the more we can understand why there's life, aka us, on Earth and not on any other planet so far. When we see crazy new planets, we get crazy new ideas, which can turn into awesome inventions that make our lives easier. Even just going into space gives us new ideas. Scratch-proof lenses, some firefighting equipment, water filtration systems, wireless headsets, invisible braces, that tiny vacuum you use to clean those crumbs in from between your couch cushions, they were all invented to help astronauts work better in space. And now they make our lives better every day. Maybe we'll figure out a new energy source someday, thanks to a far-off planet or star. Or we might discover a new compound that will make our buildings stronger or more energy efficient.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called red planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the red planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolus Dorsa. It turned out that all those years ago, this part of the red planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers, as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the red planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the red planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state deep under a layer of rock, debris, and dust under a northern plain called Vasticus Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of -80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the red planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, it's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the red planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system, that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, it could span the entire continental United States, from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the red planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet. Oceans cover over 70% of the Earth's surface, so it comes as no surprise that about 50% of the US territory is underwater. We've explored only 5% of oceans. 12 people walked on the moon, but there were only 4 manned descents to the Mariana Trench, the deepest location on Earth. Pressure is the crucial challenge of going deep into the ocean. At bigger depths, temperatures are extremely low, visibility is 0, and the pressure is so intense, it's harder to send people to the bottom of the ocean than to send them into space. You can't see it, but the pressure of the air pushing down on your body in deeper parts is so big, it feels like more than 100 adult elephants, or 50 jumbo jets, are standing on your head. The pressure is 1,000 times bigger than on the land. Meanwhile, in space, when we pass through the Earth's atmosphere, the pressure drops to 0. We're mapping the planets, but it turns out to be easier than mapping the ocean floor. NASA uses radio waves when exploring space, but this method can't be used for the ocean, since the trillions and trillions of gallons of water get in the way. The Pacific Ocean is becoming smaller, while the Atlantic Ocean is expanding. Many, many years ago, the Atlantic Ocean wasn't even there. It was formed when the North and South American continents separated. Now it's growing bigger at a rate of 2 inches per year, while the Pacific Ocean is shrinking a bit. Oceans even have their own sound, called a bloop. Its quite loud, low frequency, and pretty spooky sound was detected by scientists back in 1997. Some years later, though, other studies revealed that the bloop emanated from an iceberg, cracking away from a glacier. There are lakes and rivers in the ocean depths. It's possible because salt water and hydrogen sulfide make a combination that's much denser than the water surrounding it, which is why lakes and rivers might form and flow right inside the ocean. The world's biggest waterfall, called the Denmark Strait Cataract, is underwater too, in the waters between Iceland and Greenland. It's 11,500 feet tall, and its amount of water is almost 2,000 times bigger than the one Niagara Falls has. This underwater waterfall is possible because cold water is much denser than hot water, so cold water drops into the much warmer Irminger Sea. The longest mountain chain is also hidden in the mysterious underwater world. The mid-ocean ridge is almost 40,000 miles long. People studied only about 1% of this ridge. We know less of this chain than we know about the surface of Mars or Venus. Challenger Deep, the southern part of the Mariana Trench. That's a small valley at an extreme depth of a little bit over 36,000 feet. Imagine putting our tallest mountain, Mount Everest, into the Challenger Deep. 1.2 miles would still remain for the mountain's peak to reach the surface of the water. 94% of all living creatures are aquatic, and almost 2/3 of marine life is still not defined. So new species are being discovered all the time, including those spooky ones like the goblin shark, the fangtooth, and the frilled shark. Imagine what more's been waiting for us down there. There are also treasures hidden down below. Oceans have around 20 million tons of gold, but not in a way it can be extracted or mined with any cost-effective methods. It's dispersed all over the seafloor. If we could take it out, each person on the planet would get about 9 pounds of gold. Corals in shallow waters needed to find a way to protect themselves from the sunlight, so they developed some kind of layer that helps them feel good, even when exposed to direct sun rays. Basically, they developed a sort of natural sunscreen. Corals are living creatures. No mouth, eyes, or anything else that could say they're more than a rock, but they are in the category of marine invertebrates. A lot of the oxygen on our planet comes from the ocean. Scientists claim it's about 50 to 80%. The oxygen is produced by marine plants, mostly algae. A tsunami can be up to 100 feet tall, but waves under the surface are even bigger and can reach a height of 800 feet before they collapse. Antarctic fish have proteins inside their bodies that act as some sort of natural antifreeze. These proteins attach to ice crystals and prevent fish from freezing when the water gets too cold. When you place a seashell near your ear, it seems like you hear the sound of waves crashing on some distant beach, like a shell's memories are trapped inside. In reality, the shell amplifies the ambient noise from your current surrounding. There are 1 million volcanoes in the ocean depths, and 80% of eruptions happen underwater. The jellyfish is one of the oldest aquatic creatures, and their ancestors lived 500 to 700 million years ago. That makes them more than twice as old as the first dinosaurs, since they appeared around 240 million years ago. Sharks have also been around for quite a long time, about 400 million years. Fun fact, they don't have bones, but cartilage, the same thing our nose and ears are made of. Their skin is covered in a material that looks more like some sort of teeth than fish scales, dermal denticles. With this, their skin kind of feels like sandpaper, so it helps them be quicker and quieter. The smallest shark, called a dwarf lantern shark, is also one of the tiniest fish in the ocean, since the biggest one ever found was smaller than 8 inches. Lobsters have been around for almost 500 million years. Scientists found fossils of some kind of a huge 7-foot-long lobster, which was one of the biggest animals living at those times. Dolphins are some kind of sleepwalkers, since they sleep with only half of their brain. They close one eye at a time. Sea turtles are quite adaptive animals, and they live on all the continents, except Antarctica. Octopi are incredible marine dwellers. They have blue blood, 3 hearts, and 9 brains. The central one and the other 8 brains are distributed among their 8 arms. They also can regrow an arm in about 100 days. Sea sponges don't have a head, eyes, a mouth, bones, lungs, a heart, or a brain, but they're still living beings. A seahorse is technically a fish, even though it doesn't look like one. This specific animal has no stomach or teeth. Food goes through its digestive systems really fast, so these animals must eat more or less all the time to stay alive. Seahorses can eat more than 3,000 brine shrimp per day. There's a unique spot in the Pacific Ocean where you're farther from all your problems than in any other place on Earth. It's called Point Nemo, and it's about 1,500 miles away from the closest points of land. It's quite hard to get there. First, it's not a bit of land, so you can't actually see it. Second, even the person who discovered it back in 1992 never visited it. The ocean doesn't get struck by lightning as often as the land does, but when this happens, the results can be way worse than on the ground, since water is conductive, so lightning spreads across the ocean really fast. Cold water surrounding your body while swimming may feel refreshing, but that's not a protective layer, and you can still get sunburned. In fact, the water only reflects 10% of UV rays, while the sand reflects an additional 15% of the sun's rays. The temperature in oceans varies. Sometimes you can find water with a temperature of up to 40 degrees Fahrenheit, while there are hydrothermal vents in the seafloor too. They release water that goes up to 750 degrees Fahrenheit. Ouch. There's this thing called the Milky Sea phenomenon, a stunning scene where the water glows with such incredible light that it looks like it's not from our planet. This area is so big, you can see it shining from space. and the mysterious phenomenon usually can be seen in the Indian Ocean. Sometimes, while chilling on a beach, you can see green flashes over the horizon. That happens because the atmosphere bends sunlight when it's passing through, after which it separates the light into different colors. This is in the same way a prism splits the light into what we later see as small rainbows. Black holes have incredibly strong gravitational force pulling objects in. Even light doesn't have a chance to escape it. A similar thing happens with those found in the oceans. Yes, no need to go to space to see one of those. We have them on Earth too. It's just that they don't catch the light, but the water. They are enormous whirlpools, sometimes bigger than whole cities, and they're spinning against the main current, swirling billions of tons of water and everything else on the way. Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules other than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. Scientists are almost sure that our planet once had 2 moons. One of them was a tiny thing, no larger than 750 miles across. Unfortunately, it crashed into the other moon, which is now Earth's only natural satellite. Until recently, there was one more object orbiting our planet. It was a temporary mini-moon called 2020 CD3. This tiny space rock, no bigger than 3 feet across, was pulled into our orbit more than a year ago. Astronomers believe the mini-moon left Earth's orbit in March. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth. If you look at Earth from space, you'll see a blue ocean planet. Almost 70% of its surface is covered with water, and its average depth is 14,000 feet. But if you gathered all the water into a sphere, it would be a mere 870 miles across, just barely enough to cover Texas. And that's including all the water in the seas, oceans, rivers, lakes, ice caps, groundwater, and even those tiny droplets in the atmosphere. All Earth's air, yep, all 5,140 trillion tons of it, would make a slightly larger ball. By the way, the further away from the surface, the less dense the atmosphere is. That's why half of Earth's air is within the first 3 miles above the surface of the planet. Every 200,000 to 300,000 years, our planet goes through a magnetic pole reversal. It's not an instant process, though. It can last hundreds or even thousands of years. We live inside the sun. Its atmosphere stretches far beyond its visible surface. And even though Earth is 93 million miles away from the star, it's still within the reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. The Hudson Bay of Canada is a gravitational anomaly. This area has lower gravity than any other place on Earth. You'd weigh less standing at the equator than at one of the planet's poles. Mars has only 15% of Earth's volume and less than 10% of its mass. And still, the red planet and Earth have almost the same landmass. It's because about 2/3 of our planet's surface is covered in water. The Pacific Ocean contains more than half of the world's free water. It's also by far the largest ocean. All Earth's continents could easily fit into the Pacific Basin. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer. And still, only after 140 million years, the day on Earth will last 25 hours. The ocean on Jupiter isn't made of water. It's filled with metallic hydrogen, and its depth is a staggering 25,000 miles. That's actually almost the same as the circumference of Earth. A year on Mercury is just 88 Earth days long. This planet also has an extremely squashed orbit. Its distance from the Sun varies from 28 to 43 million miles. Even when you're standing, sitting, or lying still, you're moving at more than 1,000 miles per hour. That's the speed at which our planet is spinning through space. At the same time, You'd be moving at this incredible pace only if you're at the equator. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, the atmosphere of Earth. It also has more than 20 layers. All of them are cold and condensed. Methane gas is a byproduct of natural processes, and this very gas is present in the Martian atmosphere, which confuses astronomers to no end. Mars produces around 270 tons of methane per year. Scientists can't figure out where the gas is coming from. Earth's southernmost continent, Antarctica, is only the 5th largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. The inner regions of this continent get just 2 inches of precipitation a year, in the form of snow, of course. Mercury's surface is wrinkled. It happened when the planet's iron core cooled down and contracted. The wrinkles can reach a height of 1 mile and stretch for hundreds of miles. Lots of rocks on Earth have a Martian origin. Scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places, and it turned out these rocks had arrived from the Red Planet. The only asteroid belt in the solar system astronomers know about lies between Mars and Jupiter. There are thousands of asteroids in this region, but they're extremely widely spaced. If you had to go through that area, the chances of colliding with an asteroid would be almost non-existent. The 4 largest asteroids, sometimes called minor planets, contain half the mass of the entire belt. And still, the total weight of all the asteroids there is a mere 4% of the Moon's weight. Mercury is the most cratered planet in the solar system. Its craters are named after famous musicians, artists, and writers. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. The origin of this valley puzzles astronomers. After all, Mars isn't a planet known for its active plate tectonics. Atmospheric pressure on Venus is 92 times greater than that on Earth. Venus also has a much denser atmosphere. That's why only big meteorites can make it to the planet's surface. The smaller ones get slowed down and fall into pieces before reaching the ground. Our planet has its magnetic field thanks to scorching hot liquid metal that's flowing inside its outer core. This creates electric currents, and they, in turn, generate the magnetic field. For the past 200 years, the planet's magnetic north pole has moved northward for about 600 miles. These days, it's traveling faster than it used to, 40 miles per year versus 10 miles per year several decades ago. Volcanoes on Pluto, which are called cryovolcanoes, spit not lava, but ice. Instead of molten rock, they erupt water, methane, and ammonia. Jupiter's mass is twice greater than the mass of all the other planets in the solar system combined. Earth is the densest planet in the solar system, but this density varies depending on the planet's part. For example, the crust is less dense than the solid metallic core. Saturn's upper atmosphere is divided into layers of clouds. Those at the top are made of ammonia ice. Then, there are water ice clouds, and below them, layers of sulfur ice and cold hydrogen. Uranus rotates on its side. The reason for such an unusual position could be a powerful ancient collision, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Venus rotates in the opposite direction to the Sun. The reason might be a powerful collision with an asteroid or another space object. Iapetus, one of Saturn's moons, has an unusual coloring. It's two-toned. One of its sides is dark with a slight reddish hue, while the other is bright. Scientists haven't cracked this mystery yet. Jupiter's moon Io has hundreds of active volcanoes on its surface. It's the most volcanically active body in the entire solar system. The moon is covered in lava lakes and plains of liquid rock. Plumes of sulfur spew up for almost 200 miles. It takes light more than 4 hours to travel from the Sun to Neptune. Of all the planets of the solar system, Jupiter has the shortest day. It lasts for 9 hours and 55 minutes. Such a rapid rotation speed gives the planet its slightly flattened shape.
Ah, Earth. The third rock from the Sun. The blue planet. You get it. Its atmosphere is made up of around 78% nitrogen, 21% oxygen, and 1% argon, water vapor, and carbon dioxide. A nice balance for any living creatures to breathe. The weather here is also perfect for life to exist, unlike places like Saturn, Mercury, or any other celestial object in our solar system. We have the troposphere to thank for that. It's the densest part of the atmosphere on our planet and is 5 to 9 miles wide. It's the layer of the atmosphere that always affects our weather and secures the right conditions for life to exist and to have bodies of water. Earth is just sitting in its orbital path, minding its own business, revolving around the Sun until, BAM! Venus and Mars swoop in and spoil the fun. No one wants to leave poor Earth alone. These two relatively large celestial objects moving toward Earth will have dire consequences for our planet, starting with changes in its orbiting trajectory path. The planet's orbits in the solar system have to maintain the right balance so that nothing goes haywire. Of course, if any large object approaches Earth, it would throw our orbiting path off course. The planets will revolve around each other, which will cause plenty of natural disasters on our lands. This will also affect our rotation timing, potentially slowing it down. Days will not flow but drag by. Animals that rely on daytime will need to readjust their biological clocks. Nocturnal animals will also need to figure out how to cope with the long nights. Humans have adjusted pretty well to the 24 hours a day timing. Time itself is just a human construct to measure things. We'll have a tough time sleeping and adjusting to the stretched day. Marine animals rely on the natural current flow to migrate around the oceans. With Mars and Venus crashing the party, it looks like they will also need to find new paths. Birds migrating to other lands throughout the year will also be confused and not know what to do. In general, the Earth's temperature will rise, and massive heat waves and permanent climate changes will occur. This brings us to our next issue, the heat. The radical temperature rise will turn everything into a barren desert. It'll be summer all year long, especially if Venus is in the picture. Most of the planet will dry up and won't be suitable for growing crops. Venus is hot, really hot. Even though it's not the closest planet to the Sun, it's still the hottest. The temperatures on Venus are close to 900 degrees Fahrenheit, which will melt you like an ice cube. The lands on Venus are generally flat, probably due to the temperatures. It's mainly hot because its atmosphere is thick and traps the hazardous gases inside. If Venus inches its way towards us, it'll invite those gases to our atmosphere and compromise it. Mars, or the red planet as we know it, is very cold. That might stay the same if it starts rotating around us. It's also home to the largest dormant volcano in our solar system, which makes Mount Everest look like a tiny bush compared to a tree. With so much instability, it might just wake up one day and spew out molten lava. Mars has a very thin atmosphere, which makes the planet chilly. Its gravity is quite similar to ours. It's actually very cold and has ice caps in the poles covered with carbon dioxide. The same's true for Mercury. You can only last there as long as you can hold your breath and be in the sweet spot between the sunrise and sunset. The three planets orbiting each other will eventually collide. It's just a matter of time. And the Moon, just hanging out like a fly on the wall, will be so insignificant that something will eventually throw it off course and another planet will capture it to its orbit. Or, in the most dire case, it will collide with one of the two intruding planets. Earth will experience extreme tidal waves like nothing before. The two new planets revolving around Earth will cause a major imbalance, making our gravity shift out of control. Each tidal wave will be bigger than the previous one and will cover the dry land. Plenty of little scattered islands in the oceans will be completely submerged. Coastal cities and towns will also be home to fish. Flat countries in general will need boats to get around. Dams and dikes won't be enough to stop the water from coming in. Everyone needs to move towards higher ground to escape the floods. With the climate getting hotter, the polar caps will melt like ice cream on a sweltering summer day and add to the water level rising. Within a few months, the whole Arctic will be nothing but liquid. But wait, there's more! The crust will wear out due to the instability of the Earth's surface and fluctuating gravity. The Earth's crust is mainly made up of oxygen, which means we're basically walking on air. We might experience more earthquakes than before, and dormant volcanoes will wake up from their deep slumber. The skies will be covered in ash, making flights impossible. No one can travel by sea or by air. Importing and exporting will become history. The overall climate will get hotter, just like in Venus. The 3 planets orbiting each other and their huge mass might even unintentionally welcome other planets and celestial bodies to join the party. So, what if Jupiter decided to turn up? Now, Jupiter is the largest planet in our solar system. To give you an idea, the Earth would be just the size of a grape if Jupiter were the size of a basketball. It also has the largest storm we can perceive. That's known as the red spot, a place twice the size of Earth that has hurricane-like storms that have been going on for hundreds of years. Now, by the time you're done watching this video, you can expect the storm to still be going at it. Since the planet is huge, gravity must be quite strong here. It also has many moons, some of them of our little Earth. There will be no room for any proper space among the planets. Jupiter's moons will be thrown off course and latch onto other planets around. Some of the moons might collide with each other, causing massive debris to be displaced all over the place. The gravity of the planetary party will attract comets to enter the atmosphere, potentially crashing down on us. Oxygen levels will deplete, so the Earth's crust crumbling will continue. It'll rip open the ozone layer, causing heavy strokes of ultraviolet waves to enter our atmosphere. We won't be able to step outside for too long without some protective gear and oxygen tanks. Human civilization will change drastically. We'll all live in sheltered containers that will provide clean air and safe and filtered sun rays. The shelters will be sturdy enough to withstand frequent earthquakes. We will grow only enough crops to sustain ourselves until we leave the Earth. Since it'll only be a matter of time before the planets collide, the next step would be to create large rocket ships to fly us out of the Earth. With Mars, Venus, and Jupiter revolving close to us, it won't be easy to do so. All the space debris will be blocking us from exiting the space zone area. The only safe place outside this region will be many millions of miles away, where only single planets exist. They may or may not have the conditions to host life, but humans will have the technology to land just about anywhere with similar gravity and construct the right shelters. Eventually, Mars, Venus, Earth, and Jupiter will collide with each other and break like eggs, like a big space omelet. Don't forget the moon's crashing and breaking in the mix, but we'll already be far, far away by then, hopefully.
Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel, enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
Recently, scientists have made an astounding discovery that can change the entire course of Mars exploration. Apparently, there are oceans of liquid water on the red planet, so the future looks bright. We could use this water to support future missions, and then even relocate to Mars since we wouldn't need to worry about where to get this precious liquid, right? Well, there's one big problem. These oceans of liquid water are in Mars, so deep inside that we aren't likely to get there. At least that's what a new analysis of seismic data collected by the Mars Insight lander claims. Huge reserves of liquid water seem to be the best explanation for some seismic quirks of the red planet. So all this precious water is out of our reach. But we need to find it to solve the puzzle of the aquatic history of our blushing, dusty neighbor. And the first thing we need to do is identify where the water is and how much of it the planet is hiding.
Navigation has confirmed that the parachute has deployed and we are seeing significant deceleration.
Now, our rovers are scurrying about on the surface of the red planet, gathering all the available data on the planet's surface geology. And it's getting increasingly obvious that Mars was once covered with water. Many factors, from Martian terrains to ancient dry lake beds and deltas, suggest that there was a time when the planet was quite soppy. These days, there's still some water on and right below the surface of Mars, but it's in the form of ice and nowhere near what Mars had in the ancient past. To understand how much of it could have been on the red planet billions of years ago, we must know where all this water went. There are two spots where the water could have gone: into space or toward the interior of Mars. Then it could have been isolated as either liquid reservoirs or ice deposits. Currently, we don't have any way of measuring how much water once leaked away. But now, we finally can find out more about the gooey center of the red planet. All thanks to the Mars InSight lander. It isn't operating anymore, but from November 2018 to December 2022, it was listening to the hums and rumbles and monitoring the activity below its feet. The thing is, acoustic waves generated by seismic activity deep inside the planet can change according to the composition and density of the material these waves are moving through. And scientists can get a lot of information analyzing the behavior of seismic waves. In this case, they used a model similar to those used to map underground oil fields and aquifers on our home planet. Then, with the help of this model, they analyzed the data gathered by InSight on Mars. They discovered that the best explanation could be that there was a layer of fractured rocks whose cracks were filled with water deep under the surface of the red planet. That layer could be at a depth of 7 to 12 miles. That's why it would be extremely tricky for future missions to get to it. And still, the new discovery could help us understand the Martian water cycle. Confirming the existence of a large reservoir of liquid water can help us sneak a peek at what the climate on Mars used to be or what it could be like one day. And if once Mars had a lot of water, it could have been habitable in the ancient past and might become habitable in the future. Water is crucial for life as we know it, so underground water reservoirs on the red planet could already be habitable. Maybe, while we're talking, tiny microorganisms or even some tentacled creatures are living their lives in the comfort of their underground home. On Earth, super deep mines do host life, and the bottom of the ocean, with its immense unbelievable pressures, isn't lifeless either. So far, we haven't found any evidence of life on Mars, but for now, it sounds like this place has the potential to sustain life. InSight data has shown that there isn't likely to be a lot of water ice in the upper crust of the planet, at least in the region around the lander. But if it turns out that there is a water-rich layer deep below the surface and stretching around the entire globe of the planet, then there would be enough water to fill ancient ocean beds and even more. Now, Mars isn't the only place outside Earth where there is water or where we might one day find water. Take the good old Moon, for example. On Earth's natural satellite, water can be found all over the surface, but it's not the water you might be imagining. On the Moon, water remains mostly as ice, and it's distributed unevenly. For example, the poles of the Moon are the regions that never receive sunlight. This is the reason they're extremely cold, and it's no wonder there's a lot of ice there. The ice in these areas is often mixed with the lunar soil and hiding deep below the surface. Then there's Enceladus, the sixth largest moon of Saturn. In reality, it's not that large, just 314 miles across. In other words, this moon is small enough to fit inside Arizona. Ooh, we should try that. Well, interestingly, when the Cassini space probe first arrived at Saturn, researchers were expecting Enceladus to be a frozen ball of ice. But what they saw was plumes of icy particles and water vapor erupting from geysers on the moon's surface. It was clear that there was a massive ocean between the moon's rocky core and its icy shell. Then there's Jupiter's moon Europa. Scientists think that this world is one of the most promising places in the solar system when it comes to searching for new life forms. That's because Europa has a huge saltwater ocean as deep as 40 to 100 miles. And even though it's under a layer of ice that is likely to be 10 to 20 miles thick, it's still potentially habitable. Astronomers believe that plumes of water might erupt from cracks in the ice shell and release the contents of the moon's ocean into space. The temperature, pressure, and chemistry are very different on Europa, and astronomers aren't sure yet how the ice behaves there. That's the main reason they haven't figured out yet how deep or large the water reservoirs on Europa are and how long they need to refreeze. But out of all the places where we could find water in the universe, the most bizarre is probably open space. In 2011, two teams of astronomers discovered a cloud of water floating freely among stars. It was the largest and farthest reservoir of water ever detected. So this massive cloud of water vapor surrounds a black hole. But not just any black hole. This one's a quasar, located 12 billion light-years from Earth. The conditions around this quasar must be really special to create such an enormous amount of water. This cloud contains 140 trillion times the volume of all the water on Earth. That's enough to give every person on the planet a whole planet's worth of water 20,000 times over. Sounds wild, doesn't it? But there's something even cooler. Astronomers think this water cloud formed just 1.6 billion years after the universe began. This discovery is yet another sign that water has been around all over the universe, even in its early days. But here's the kicker. Until they found this, scientists had never detected water vapor so far back in time. Sure, there's water in our Milky Way galaxy, but most of it's frozen solid in ice. This discovery really pushes the boundaries of what we know about water in the universe.